Hi everybody, today I'm gonna talk about ushow, the software that we developed to visualize the data on unstructured grids. It also can be used for structured grids as well. I will show you a couple of examples of that, but the general idea was to develop something that will allow us to look at the, in particular, FESM data, which is formulated on unstructured grids. It's an ocean model. And we also was inspired by NCView that allows to very quickly look at the data and see what is going on there. So first things first, ushow. Let's open some FESM data. So FESM core. We go for temperature. We can use wildcards to open it. We need mesh information because FESM doesn't come with mesh information, and that's our mesh file. And this is the first image that we can have. So we can increase it a little bit. So you can see it's there is a field. It's a temperature field. It looks not super pretty, but it's good enough to have a look at it. The reason why it's not look super pretty, for example, you have like really huge Mediterranean Sea, is that we use nearest neighbor interpolation. So all the points in ushow are treated, at least in the default mode, are treated as cloud of points that doesn't have any connection between each other and have coordinates, and we just put them on the map by using nearest neighbor interpolation. So what you can do, there are a few things. You can move forward, you can move backwards, you can have an animation, you can change the color bars, color scales, and you can go change the minimum, the max. This is like changing the minimum values. This is changing the maximum values. So you can play around a little bit here. Then you can decrease, increase the size of your view. You can also save it in the same folder from where you started the application. And then you can have a range set. So in this case, we can explicitly, so instead of this min max buttons, you can say -2 and I don't know, 35, and you get this set. Another thing that you can do, you can click on any place in here and you will get, hopefully, the time series for this point. So you should close it with this close button, because if you close it with this button, it will close the whole application. That's the same behavior that is familiar for people who use NCView. The same thing is for this range, so you should not close it here. You should say OK or cancel. And then the last thing is that you can go down with through the depth here, right? And you can use right click or left click to move forward and backwards. So that's the basics of it, and that's the main functionality. Then we can improve some things. So by default, we interpolate to the 1 degree resolution data, so we can increase the resolution to 0.25, to quarter degree. So it takes a little bit more time and gives you a bigger picture, right? So you have here now much more detail, but it's still fast enough to go through each individual frames and give you some information of what is going on. If you have version that is compiled with something that is called YAC, it's yet another coupler. It's a coupling software that also have a lot of interpolation options, and we use some of them. So if you have YAC, and YAC understands your connectivity information here, we can use it, and this gives you much better result in terms of like visual much better visual result, right? So you can see that now Mediterranean already look like Mediterranean. So this interpolation understands the connectivity and uses information to do interpolation. It's also pretty fast, so as soon as you did the interpolation, that's just reused for the rest of the fields. So for low resolution data, it actually makes a lot of sense to use that with Yak because it's fast enough and give you much better view. All right, so let's say then that we also want to have some more closer look at some particular parts of our simulation. So we can select the region, minus 100, minus 30, 20, oh, well, 30 is okay, 60. So here is the box. We can make it larger, and you can see here is our Gulf Stream area where we can have a closer look. But again, so this model is about 1 degree resolution, and here maybe a little bit higher, so you don't see like really a lot of details. And I think what you usually also want to do is you want to look at the polar regions. So we can say polar north, and we get our polar region as well. We can increase it. We can go down with again with through the depth, and you can see for the default Yak interpolation, if you go through the depth, it doesn't look too nice because it's kind of builds interpolation for the surface, and reuse it for the bottom, which is not necessarily the best option in this case. And for this, we have an option that is called Yak 3D. And now if you open it, then well, go down, so you can see that it starts to build interpolation for each of the levels, and you don't have these artifacts anymore. You can again just move forward with the animation. Maybe for you the animation is not fast enough. This is also something that you can change. You can add the delay, and let's put it 20. And yeah, increase a little bit. And here is how fast it can go afterwards, right? So, I mean, again, the data are pretty small. That's why things are actually working pretty fast. So let's try to look at something that is a little bit ushow, a little bit higher resolution. So it's a NG mesh, NG5 mesh. We also look at the temperature, 2001, and we still need a mesh information. NG5 phase mesh diac. So you see now it doesn't really work that quickly, right? Even with nearest neighbor interpolation, it takes some time to build this interpolation weights, but still, I mean, I think it's reasonable time for such a big mesh. Again, we can increase it a little bit. So for this high resolution mesh, I mean, you see that there probably will be much more interesting details here, and it's a little bit of a pity to have this ugly nearest neighbor interpolation like this. You can actually fix it without employing the Yak interpolation, because Yak will have a little bit, well, I mean, will take a little bit more time than the nearest neighbor. So what you can do, you can control the interpolation radius, because we know that the lowest resolution on NG5 mesh is 13 kilometers, and we can just put it here. Wait a bit. And hopefully at some point we will get the data. right? So it looks much better now. So because the interpolation radius is smaller, it still was relatively fast because we use low resolution target grid, just 1 degree. Well, let's just for the completeness put well I mean 1/10 of a degree is probably too high. We'll wait a little bit too long, so let's try 1/4 degree resolution and see what kind of details we will be able to see on the resulting map. But again, takes some time, and that's why YAC options will take like 3 times longer, I would say. So might not be ideal for you. But if you want a best result, also can use YAC option. That's also fine. If you're ready to wait a little bit. Okay, this is how the 1/4 degree interpolation look like. So initial fields, as you can see here, are smooth, but it's because it's just the beginning of the simulation. You see that then models start to kind of add some dynamics into the fields, and start to look much nicer. It's not the best color bar for this, so here we go. So that's our high resolution data, relatively quickly. Well, I mean, relatively fast animation as well, so we can also increase the magnitude a little bit if we really want to go into detail and don't want to make a region out of it. But I mean, if we want to go to the Arctic and see, I mean, FESM has pretty nice sea ice in the Arctic, so let's try ice also 2000. I mean, let's do the wild card here, and yeah, I think should be fine. In the Arctic is actually just 5 kilometers, but we put 6 just for. Oh wait, I didn't put the polar, right? Polar north, and let's see what we will get. So you see, it's constructs the the Lambertical area projection for the pole. There is a cutoff that you also can control. So if you want a little bit larger area, you can still get it. And the same thing is for the South Pole. Well, so for the southern hemisphere is available as well. So here we go, and this is how sea ice. Right, again, so fun thing is to, well, I mean, that's black and white is also not bad. But I mean, my favorite one is this one from which is called Curl. Looks pretty cool with all the cracks available for the sea ice. All right, so this is our high resolution simulation. So you can see that with FESM you can look at the things very easily. How about other models? So ushow not only gives you possibility to look at the different unstructured meshes, but it also works with several formats. So by default it's NetCDF, but you also can compile it with grip support and with ZAR support. And if you have that, you can open things like Era 5. So we have here example of Era 5. Well, let's see what's in the folder. You show Era 5 and then select one of them, or maybe we just do the whole year. Oh well, you see that it's yeah, for the grip files it's a little bit slower to put them together, but it's done. And this again, interpolation to 1 degree. You can always change that. Let's select some beta color bar, I don't know, something like this, and let's go. So you see that's your Era 5 data from the original grip. Yeah, so the dates are also working pretty fine, and yeah, pretty useful. And again, this is the error 5. They are distributed on reduced Gaussian grid, which is not entirely unstructured, but it's very natively used with unstructured kind of grid approach. So yeah, you can have a look at them as well. Another thing that you can look at is the data on the hill peaks ushow, and here we have data 2D data on hill peaks that is also distributed in a ZAR format. And again, for this to work, your data has to come with latitude longitudes. So for the hill peaks data that we have here, they also come, although hill peaks lat long is easy to construct from the hill peaks description. This data in particular, they just come with latitude longitude, so that's super easy to handle, but they are pretty big. So that means that it's, well, it will take some time to interpolate them. Again, there will be not the full beauty of this data because we interpolate 1 degree, and probably not the best idea for this particular data. But for the sake of demonstration, I think it's fine. So again, ZAR data working and in the full glory. Then we have the same thing, but we show hill peaks 3D ZAR, but for 3D those data are much lower resolution, so it will be pretty fast. Again, increase it, and you can go through the vertical levels as well with ZAR. So this is what why we have this 3D data here. I mean, you see that there is no depth information in this ZAR data file. So I mean, we just replace it with numbers, but you have to know the depth levels somehow by yourself. All right. What else? So in our group we use MIT GCM quite a lot, so we also have support for that. MIT GCM uses custom binary format to distribute the data, but ushow is supporting them, so we can just say MIT GCM. In order in order for this to work, you have to have the coordinate information, like grid information, available also in the folder where you have the data, right? So this kind of things that MIT GCM produces, they all have to be there, and then ushow will just give you the data. Well, I mean, this one is nice because you see that it also supports multi variable in one go. Before we were only looking at the data where we have only one variable. So for example, we can go to the temperature, salinity, vertical levels also work. Here, this grid for MIT GCM is an cube sphere grid, so there was some trickery involved in order to make the U and V look right, but I mean, we managed, so you can now explore your data from MIT GCM also in a similar interface to everything else. So the resolution of this simulation is very low, so that's why there is not much detail. Right, so, and the last thing that I would like to show is the NEMO, which is also NEMO FOSSI example that is provided by our GeoMark colleagues, and that also works. So, I mean, the drill is the same as before. Here is the data, so let's select the temperature, make it a little bit larger, and you see that everything is working. If you press, hopefully, yeah, you have it as well. So NEMO data works as well. So one last thing, really last thing that I would like to show is that everything that you saw here is possible to also get with something that is called uterm. So uterm allows you to not to use the X to visualize the things, but to visualize things directly in your terminal. So if you you can rotate between the methods of how to look at your data by pressing M key. So you can see that, well, I mean, there is some explanation of what kind of things you can do in this upper left corner. So M will change between different modes of displaying your data. You can press space bar, and then you can see that, okay, we have the animation, and yeah, we can cycle through them, and also do, like, I mean, go through depths and so on and so forth. At Q gives you, like, makes you exit the uterm. So let's make the resolution a little bit higher and see what we will get. So if we get higher resolution, you see that, I mean, the resolution on the screen doesn't really change too much. And the reason is that it uses Unicode symbols in order to display your data. What you can do, you can decrease the font of your terminal to the absolute minimum and run it again, and now you will have something that looks much better. Well, I mean, if you make an animation, it has this flickering, but if you go like one by one, you can see some better details. And again, so you don't have to have an X, and if by some chance there is no X support on your X11 support on your machine, so you still can do some visualization as well. And it's also just fun to have this. All right, that was it. So thank you very much for listening. Try ushow, try uterm, open issues, and yeah, maybe do some feature requests and have fun looking at your data and exploring them. Bye bye.